sir. We are the group 4 and I am Decadet Kanama Jeff Shagford A and I am here with Karasana Mark Joseph B and Kabalite Joshua Q. Course is MTech 102, period finals TTH 10:30 to 12 p.m. Week 1, Session 1, topic is Sextant altitude by sun and planet. Learning outcomes. At the end of the session, the student shall be able to understand how to get the sextant altitude using the sun and planet. So how to calculate the sun's and planet altitude? So step 1 is your latitude is a number between 0 degrees if you live at the equator and 90 degrees if you live at the north or south pole. Most people in the United States are between 25 degrees north latitude and 45 degrees north latitude because the Earth's circumference is about 25,000 miles and there are 360 degrees in a circle. Each degree of latitude works out of a little less than 70 miles. Step 2. Determine the sun's equinox altitude. The Earth's eye is tilted 23.5 degrees from the line perpendicular to its plane of rotation like a spinning top that has begun to wobble. This is what causes the seasons and is also the reason for the sun's highest altitudes varies. On about March 22 or 23 and again on about September 22 or 23, Earth passes through the equinox, Latin for equal night. On these 2 days, the Earth gets 12 hours of light and 12 hours of darkness and the sun climbs to an altitude is equals to 90 L in degrees about the horizon. Step 3. On determining the sun's solstice altitude. Starting on the vernal equinox on the northern hemisphere on March 22 or 23, the first day of spring, the amount of time the Earth spends on light continues to increase and the sun climbs at a progressively higher point of each day. After 3 months on June 22 or so, the summer solstice, the first day of summer and the so-called longest day of the year, arrives because of the 23.5 degrees tilt mentioned above. The sun and noon is in Boston is now 90 minus 42.36 plus 23.5 is equals to 71.14 degrees above the horizon. This is about to 80% for the way from the horizons to the zenith. 6 months later, on December 22 or 23, the autumnal equinox has come and gone. The winter solstice arrives. On this day, the first day of winter and so-called shortest day of year, the situation from the summer is reversed, and the sun only reaches an altitude of 90 minus 42.36 minus 23.5 is equals to 24.1.
So step 4, factor in the declination for today. So the variation owing to the Earth's tilt is called the declination. It is a positive number in the spring and summer and negative number in the fall and winter, varying between the values of 23.5 and negative 23.5 degrees. The equation for calculating the altitude above the horizon or on any given day is altitude equals 90 minus L plus D. So in our initial examples, on the equinoxes, D was 0 and was therefore not explicitly included. So to determine the declination for today and the sun's altitude, you can use the NOAA Solar Calculator or the Kison Calculator, both online. If you don't have access to one of these, you can make a decent guess as long as you know the date and the approximate latitude. For example, it is early May and you're in Miami, Florida. You know the sun's declination is about halfway between 0 to 23.5 because spring is half over and your latitude is about 25 degrees. Therefore, you can estimate that sun will climb to an elevation about 90 degrees. So the calculation is 90 minus 25 plus 11.5 equals 76.5 degrees.
Good day everyone. So for today, I am going to discuss about the terminologies for us to not get confused during the solution. First is the sextant altitude. The altitude of a celestial body as measured by a sextant. It is the angle measured in a vertical plane between an artificial or sea horizon and a celestial body without application of any correction. Next, index error means that your code is trying to access an index that is invalid. This is usually because the index goes out of bounds by being too large. For example, if you have a list with 3 items and you try to access the fourth item, you will get an index error. Next, observe altitude. Is the altitude that a star is seen to be with a telescope. This is where it appears in the sky. The observed altitude is always greater than the apparent altitude, which is the altitude that a star would be at if there were no atmosphere, sometimes called true altitude. Height of eye, distance that your eyes are off the surface of the water or ground. Apparent altitude, the altitude that a star would be at if there were no atmosphere, sometimes called true altitude. This is usually calculated from an object celestial coordinates. Apparent altitude is always lower than the observed altitude. Total correction. They, they cover all altitudes from 0 degree to 90 degree and the heights of eye from 1 to 48 meters. The tables provide corrections to apply to both the upper and lower limbs of the sun and are in two parts. True altitude is measured from the Earth's center in relation to the celestial horizon and is the angle of RCX. Point O will be approximately 6,367 km from the center of the Earth, and so it would seem that the visible horizon is bound to be slightly offset from the celestial horizon. So for today, we are going to find the true altitude of a planet. So we have our example. Find the true altitude of a planet Saturn on 5th of October 2005 when the sextant altitude was 35 degree 30 minutes. Height of eye was 8.6 meters and index error was 0.4 on R. So there is the solution. Sextant altitude 35 degree 36 minutes. Index error 0.4 minutes. Since it is on arc, we have to subtract it. If it is off the arc, we have to add it. So, observed altitude is 35 degree 35.6 minutes. So, for the tip or height of eye, so let's go to the nautical almanac. So, let's go to the dip table. So, we have to find the 8.6. So, it lies between 8.5 to 8.8 with a with a height of 5.2 minutes. So let's going to subtract it to get the apparent altitude, which is 35 degree 30.4 minutes. So for the total correction, so again, we're going to find it in the nautical almanac. So 35 degree 30.4. So it lies between the 35.40 to 37.48 with a total correction of 1.3 minutes. So we are going to subtract it again to get the apparent altitude of 35 degree 29.1. So for the additional correction, let's go to the correction table for planets. So we have here 0.3 minutes. So we're going to add it for us to get the true altitude of 35 degree 29.4 minutes.